Good morning, children. Yesterday we did ammonia, manufacture of ammonia by Haber's process. Today let us start manufacture of nitric acid. What is the formula of nitric acid? HNO3. HNO3. Okay, children. Now, so first we will do the preparation. Ammonium nitrate, when it is treated with the H2SO4, we have sodium hydrogen sulfate plus HNO3 is formed. That is the lab preparation of nitric acid. Clear, children? How will you prepare? Sodium nitrate, when it is treated with the H2SO4, we will have H2SO4, sodium bisulfate and HNO3. Now next is manufacture of nitric acid by Oster's process. Now here, when ammonia is treated with oxygen, it will give nitric oxide and H2O. The nitric oxide further react with oxygen to form 2 moles of NO2, that is nitrogen dioxide. Now the NO2 react with the H2O to form nitric acid and NO. This is the important reaction, children, for the board exam. Manufacture of nitric acid by Oster's process. Okay, children? Now next, properties of nitric acid. Now, nitric acid we have seen in the class 11 in the laboratory. It is a colorless liquid, children. Laboratory grade nitric acid contains 68% of HNO3 by mass and has specific gravity 1.504. Okay. Now concentrated nitric acid is a strong oxidizing agent and attacks most metals except noble metals such as gold and platinum. What did I say? Concentrated nitric acid is a strong oxidizing agent, okay, and it attacks the most metals except gold and platinum. The products of oxidation depends upon the concentration of the acid, temperature and the nature of the material undergoing during oxidation. Now here copper. Copper reacts with the HNO3. Here 8 moles of HNO3. Dilute HNO3, children. Copper reacts with the dilute nitric acid to form copper nitrate, NO and H2O. Note the difference between dilute and concentrated. Children, copper reacts with the nitric acid to form dilute nitric acid to form copper nitrate and NO. Copper also reacts with the concentrated nitric acid to form copper nitrate. Copper nitrate is the common product, children, please note down. Concentrated nitric acid, dilute nitric acid react with the copper to form copper nitrate is the common product. Along with the copper nitrate, NO is formed and in one reaction NO2 is formed. Now next, zinc react with the nitric acid, dilute nitric acid to form zinc nitrate and N2O. And similarly, zinc react with the concentrated nitric acid. Now here also, children, dilute and concentrated reactions mean dilute nitric acid, concentrated nitric acid. The product is zinc nitrate and zinc nitrate. But the side product, the oxide of nitrogen is different. With the dilute, N2O is formed and with the concentrate, NO2. Please note this point, children. Concentrated nitric acid, when it is treated with the copper, NO2 is formed. Here also, concentrated nitric acid, when it is treated with the zinc, NO2 is formed. Okay, children. Now next is brown ring test, one of the important tests. The brown ring test of nitrates depends upon the ability of the formation of the Fe plus 2 ions to reduce nitrates to nitric oxide, which react with the Fe+2 ion, a brown colored complex. Okay children, this test is usually carried out by adding dilute ferrous sulfate solution to an aqueous solution of nitric acid and then carefully adding concentrated sulfuric acid along with the sides of the test tube. Okay children, now the reaction NO3 negative plus 3 Fe+2 and 4 hydrogen ions will have NO plus 3 Fe+3 plus 2 H2O. Then FeH2O, the complex compound, react with NO to form FeH2O 5 times NO. So this is the brown color children. FeH2O 5 times, please write and practice. Brown color, important for your board exam. Brown color. Okay children, that closes concentrated nitric acid preparation and properties. Now let us start the allotropic forms of phosphorus. Phosphorus is mainly formed in two allotropic forms. One is white, three allotropic forms, red, white and black. Phosphorus exists in three allotropic forms. What are they? Red, black and white. White phosphorus is a transparent waxy solid. It is poisonous, insoluble in water but soluble in carbon disulfide and glows in dark. Dark means chemiluminescence. It glows in dark, shines in dark. It dissolves in boiling NaOH solution in an inert atmosphere giving pH 3. Okay children. Now white phosphorus is less stable. So therefore, now what did I say? Allotropic forms of phosphorus are three forms are there. White, red and black. Now the white phosphorus is less stable. So therefore, more reactive than the other solid phases under normal conditions because of angular strain in the P4 molecule. Now P4 plus 5O2 will give you P4 plus 5O2 will give you what is formed? P4O10. P4O10. Clear children? Now red phosphorus. Red phosphorus is obtained by heating white phosphorus in an inert atmosphere for several days. When red phosphorus is heated under pressure, a series of phases of black phosphorus is formed. Red phosphorus, it possesses iron grey luster. So it is odorless, non-poisonous and insoluble in water as well as carbon disulfide. Chemically children, red phosphorus is much less reactive than white phosphorus. Clear? Chemically, the red phosphorus is much less reactive than white phosphorus. And red phosphorus does not glow in dark. But white phosphorus, it glows in dark. Is it clear children? Next point. Now, black phosphorus. Black phosphorus is two forms, alpha black phosphorus and beta black phosphorus. Okay, black phosphorus is having two forms. One is alpha black and beta black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated in a sealed tube. It can be sublimed in air and has opaque, monoclinic or rhombohedral crystals. Now it does not oxidize in air. Beta black phosphorus is prepared by heating white phosphorus under pressure. It does not burn in air. Okay children?